Hello Year 10s and welcome back to Mathematics. In this video we're going to be looking at the next section in our topic of linear relationships, and what we're going to be talking about is what parallel and perpendicular lines are. So in this video we want to be able to achieve three things by the end of today. We want to be able to explain what parallel and perpendicular means, we want to identify parallel lines from the rule, and we want to identify perpendicular lines from the rule. So those are the three things we want to be looking at today. So let's quickly go through what it means for the line to be parallel and what conditions are required for this. Now, let's have a look at what it means for two lines to be parallel. Now, two lines are parallel if they never intersect. So if we draw two lines on a Cartesian intersect. If we draw two lines on a Cartesian plane and these two lines never intersect, those are what parallel lines are. Now, this happens if they have the same gradient. So in a couple lessons ago, we talked about what the gradient is. The gradient is just a measure of how steep your line is. So if two lines have the same gradient, that means that they are parallel. So here, general rule, m1, so the gradient of our first line, so that's what this 1 at the bottom tells me. If m1 is equal to m2, if the two gradients are equal, so the gradient of my first line and the gradient of my second line, that means that they are parallel. Okay, now the other type of lines that we can have is perpendicular lines. So perpendicular lines, two lines are perpendicular if they touch at 90 degrees. So if two lines meet and they meet at 90 degrees, that means that they are perpendicular. And the rule that we have for this is that it's not that the gradients are equal, but actually they follow this following pattern. If I take the gradient of the first line and multiply it by the gradient of the second line, that needs to be equal to -1. If that equals to -1, that means that two lines are perpendicular. So parallel means that two lines never intersect. So what we need for that is that the two gradients are exactly the same. If the two gradients are exactly the same, that means that they are parallel. If two lines are perpendicular, that means that they touch at 90 degrees. And so what we need for that is m1 times m2 is equal to -1. So the two gradients, when we multiply them together, give me -1. Now let's just give an idea of to visualize what this looks like. Here I have a Cartesian plane, and I've actually drawn a line on here. So this is my starting line. Let's just call this this one line 1. Now, in order for it to be a line to be parallel, it needs to never touch. So what we need to do is actually have a line where the gradient is exactly the same. So here I'm going to have a line, I'm going to find the gradient. So here on my, it's this particular angle. So if I draw another line on my Cartesian plane, say for example over here, with the same gradient, these two lines would be parallel. So this is an example of a parallel line. So this is a parallel line. And so the condition for parallel lines that we said was m1 is equal to m2. So if our two lines are parallel, it means that they have the same gradient. Now on the other end, we also had perpendicular lines. Perpendicular lines means they touch at 90 degrees. So if I take my line here and I just rotate my line, so I'm going in the other direction now, and I draw a line like this, I'm going to draw it in green. Notice here that my new line that I've just drawn, it touches the first line that we had at 90 degrees. So that's what it means for a line to be perpendicular. And so the condition that we had was m1 times m2 is equal to -1. So that's what it means for lines to be parallel and perpendicular. Parallel means that they never intersect. Perpendicular means that they touch at 90 degrees. Okay, so what we want to be able to do is we want to be able to identify whether or not lines are parallel or perpendicular based on their rule. So last lesson we talked about the gradient intercept form, and what we want to be able to do is identify whether or not two lines are parallel or perpendicular. So the way that we do this, we're just going to identify the gradient of our two lines and see which of those it matches up with, whether or not they're equal or if they multiply to give me -1. So let's have a look at this example. Example 1, determining if lines are parallel or perpendicular. Decide if the graphs of each pair of rules will be parallel, perpendicular, or neither. So let's have a look at this first example. I've got my two lines here. Y is equal to 4x plus 2 and y is equal to 4x minus 6. Now, in the last lesson, we actually talked about finding the gradient of these lines. And these lines are written in gradient intercept form. And so, if I want to find the gradient of these lines, what I'm going to say is, let's call this line the first line, and this one the second line. So all we need to do is look for the number before the x. So here, this one has a gradient of 4. So I'm going to write m1, the gradient of my first line is 4. And on the other end, m2 for the gradient of my second line, well, what's the number before my x? It's also 4. Now for this example, have a look at those two numbers. m1 is 4, m2 is 4. Because they have the exact same value. Because they are the same values, therefore, what can we say about these two lines? Because they have the same, if m1 is equal to m2, so I'm just going to write here, m1 is equal to m2, therefore we can say that these two lines are parallel lines. So if we have two gradients which are the same, if the gradients are equal, that means that they are parallel. Okay, let's have a look at the next example over here. I've got negative 3x minus 8 and 1 over 3x plus 1. Now, this one here, let's just do the exact same step. When we just want to first identify the gradient of these two lines. So this one's my first one, this one's my second one. I'm just going to call this one line 1, line 2. Okay, m1, the gradient of my first line is equal to, it's just a number before my x, and here it just happens to be negative 3. So negative 3. And my second one, m2, it's going to be, well, it's a number before my x here, which is a third. So I'm going to have a third for my second gradient. So here, we can immediately tell that these are not equal. Negative 3 and a third are not equal. So what we want to check is if we multiply them, will it give me negative 1? So what I'm going to do is I'm going to write here, m1 times m2. So here this will just become, that would be equal to negative 3 for m1 times 1 over 3 for m2. Now negative 3 times 1 over 3, if you're not sure how to do that, you can chuck this in your calculator. Negative 3 times 1 over 3, that gives me negative 1. Excellent. So here, this will give me negative 1. Now if my two gradients multiply to give me negative 1, that means that they are perpendicular. So here I can say these are therefore perpendicular. Ooh, let me just write this a little bit cleaner. So, if we want our two lines to be parallel, we need to just check that their gradients are equal. If they're perpendicular, we need to make sure that they multiply to become, the gradients multiply to give me negative 1. And so that's how I can check if lines are parallel or perpendicular. Firstly, we're going to find the gradient of our two lines, and here I just labeled them as m1 for the gradient of my first line and m2 for the gradient of my second line. Then once we've done that, we're just going to look at those values. If they're equal, great, they're parallel. If they're not, then we want to just check, we multiply those two numbers together. If that gives me minus 1, that means it's perpendicular. Now if it doesn't give me any of those two values, so it's either if it's not equal or if it doesn't multiply to give me negative 1, that just means it's neither parallel or perpendicular. Okay, so that's how we can identify if lines are parallel or perpendicular. The thing that we want to do from here is we want to actually be able to find the equation of a parallel line given certain conditions. So that's what we're going to be having a look at this next section. So finding the equation of a parallel or perpendicular line. Now here's a few steps I want you guys to have a go to use when you guys are doing this. So finding the equation of a parallel or perpendicular. First step, write the gradient intercept form for a line. Now last lesson we actually looked at the gradient intercept form, and that was just y is equal to mx plus b. And m was the gradient of our line, and b was our y-intercept. So that's the first thing we're going to do. We're just going to write down the gradient intercept form, no matter what the question is. Then, what we want to do is we want to identify the gradient of the line and replace it in the value of m. So we look at the question. We go, okay, they tell me that this line has to be parallel to a particular value. That means that my gradient is going to be equal to that value. Or if it's perpendicular, we just use the fact that when we multiply the two gradients together, it should give me negative 1. Okay, then the other thing that we're going to do is these questions are going to give you a coordinate. And what we want to do is we want to substitute the value of the coordinate to find the y-intercept. So what we want to do is then after we've figured out what the gradient is, we put in the coordinates of that point. we find the x value and the y value of our coordinate, and we substitute that in. So let's have a go at a couple of questions where we need to do this. We're going to actually go through 2 sets of these questions. So let's have a look at these first ones. Find the equation of a line given the following description. So here we've got 2 questions that we want to have a go through. A line passes through 0, 2 and is parallel to another line with gradient 3. So what I'm going to do for the first one, the first step I'm going to do is just write y is equal to mx plus b. I'm going to write down the gradient intercept form. Then I'm going to have a look at the question. Well, the first thing I want to do is find the gradient. Now here, we get told the line is parallel to another line with gradient 3. Now if I know the other line has a gradient of 3, that means in order for my line to be parallel, my line also needs to have a gradient 3. So here, I'm going to just replace my m in my gradient intercept form with 3. So I'm going to write here, m is equal to, so it's going to 3. So we're going to have 3x plus b. Okay, so that's the first thing. After we've written down the gradient intercept form, we're going to find the gradient. And so that's based on what the question tells me. Here we got told it's parallel and with the gradient 3. So that tells me that my line has a gradient of 3. Okay, final bit is that it tells me that the line passes through 0, 2. So what I'm going to do is I'm going to write on the side here 0, 2. Now if you remember with our coordinates, our 0 is our x value and the 2 is our y value. And so what I'm going to do is I'm going to substitute these 2 values into my equation, and that will give me a value for b. So let's do that. I'm going to replace x with 0. So if you have a look at my equation, y is equal to 3x. I'm just going to replace the x with 0. So here this becomes 3 times 0 plus b on my right hand side. I'm going to replace y with 2. And so here I'm going to write 2 is equal to that. Okay, let's just simplify this a bit. Here I'm going to have 2 on the left hand side, nothing changes to it, is equal to 3 times 0 is 0 plus b. And so what this means is, when I have 0 plus b, that just will leave me with b, so I'm going to have b is equal to 2. And so putting this all together, what this means is I can just replace b, this value of b, my y-intercept, back into my equation over here. So my final answer is going to be y is equal to 3x plus 2. So that's how we answered these questions here. What we want to do is we firstly want to identify the gradient of the line that we are, actually, let's try that again. The first step we want to do is we want to actually write down the gradient intercept form. Y is equal to mx plus b. Then we're going to find the gradient that my line is going to follow. So here, in this case, we knew that it was parallel to a line with gradient 3. So that told me that my gradient is going to be 3. So that's what I did here. I replaced the m with 3. Then we also look at the point or coordinate that we get given in the question. Then we replace the x and y values with those in the coordinate, and then we solve for b. And that gives me a b value of 2, and we just put it back into my gradient intercept form. Okay, let's have a go at the next one. Part B. A line passes through 0, -1 and is perpendicular with another line with gradient -2. Now this one requires a little bit more work, but that's okay, we'll go through it. First step, we're going to write down the gradient intercept form. So I'm going to write here, y is equal to mx plus b. Okay, second step after that is we're going to find the gradient. Now here in this question, they tell us that the line is perpendicular with another line with gradient -2. So what this means is there's another line with gradient -2, so I have an m of equal to -2, and I want to find my missing gradient over here. Now if it's perpendicular, what we know is when I multiply these 2 gradients together, let me just write this as m1 and m2, when I multiply these 2 gradients together, it will give me -1. So let me do some working out on the side here. Now I know m1 times m2 is equal to -1. And so if m2 is equal to -2, I'm just going to replace m2 with -2, like that. So if I want to find my gradient, that's just going to be, well, if I had times it on this side, to get rid of that multiplication, I need to divide. So I'm going to divide both sides by -2. So here I have -1 over -2. And if I put that in my calculator, I just get -1 over -2, 1 over 2. So here the negatives will cancel out, and so I would be left with 1 over 2. And so my gradient is just 1 over 2. And I can replace this value of 1 over 2 in my equation here. So that's what I'm going to do. So y is equal to a half x plus b. So that's the first piece of information we needed to find, the gradient. And here, because it's perpendicular, we need to use the fact that when I multiply the two gradients here, so the gradient of my line, this one here, and the gradient of that other line, -2, when I multiply that together, it will give me -1. Okay. Then from there, we want to find our y-intercept. And the way that we do this is we substitute our point. So here, the line passes through 0, -1. So I'm going to substitute this point here, 0, -1. I'm just going to write on the side here, 0, -1. And so just like I did before, x value is 0, y value is -1. So I'm going to replace x with 0 and y with -1. So if you have a look here, I've got y over here. I'm going to replace it with -1 is equal to a half times x, which is 0, plus b. So therefore, 0 times a half will just give me a half. So this means that b is going to equal to, well, b is just left over here. So b is equal to -1. And so my final step is just writing this all together. So therefore, my line is going to be y is equal to a half x minus 1. So just in the case you're not sure, this b value goes into here, -1. And my m value was from earlier up here. And I put it in here as well. And I just put it into here. Okay, so that's how we find the equation of a parallel or perpendicular line for these examples. We're going to have a look at two more examples, and in these following two examples, we follow the exact same steps. We follow the exact same steps, but here we're going to need to do a little bit more work with the coordinate that we are looking at. So let's have a look here. This one, part A. Find the equation of the line that is parallel to y is equal to -2x minus 7 and passes through 1, 9. For these questions, we're still going to do the same thing. When we're finding the equation of the line, we're going to start off with y is equal to mx plus b. We're going to write out our gradient intercept form. Now, if you have a look at this question, the first thing we need to do is we need to find the gradient. Now, they tell me here that it's parallel to this line here. So what we want to do is we want to make sure that our line that we're looking at here has the same gradient as the line up here. Now, if you have a look, what's the gradient of this line over here? Well, the gradient of this line over here is going to be m is equal to the number before x, -2. So what this means for me here is that m is also going to need to be equal to -2. So for my gradient of my line that I'm looking for, the equation of my line also needs to be -2. So I'm going to actually just replace m with -2. So here this just becomes -2x plus b. So I've replaced m over here with -2. Okay, that's the first step. Then the next bit is we want to substitute the point that we get given. So here in this question, it passes through 1, 9. So I'm just going to write down my point, 1, 9. My x value is 1 and my y value is 9. And so what I want to do is I want to substitute these values into my equation. So wherever I see y, I'm going to replace it with 9. And wherever I see x, I replace it with 1. So here, if you have a look at my equation, I have y on the left-hand side. So that becomes 9 is equal to -2 times 1 for the x plus b. Okay, let's start to simplify this. On my left hand side, that 9 doesn't change, is equal to -2 times 1 just gives me -2 plus b. And what we want to do here is find the value of b. Now here on the right hand side, I have -2 plus b. What I want to do is just remove that -2 and move it to the other side so I have b just by itself. So here I'm going to have b is equal to, well, if I move that -2 to the other side, it becomes a +2. So 9 plus 2. And so here, b is just going to be equal to, 9 plus 2 is 11. And so here, this is my other value that I'm going to have. And so what I want to do is I just replace it in my equation. So therefore, final step, the equation of my line is going to be y is equal to -2x plus 11. So if you're not sure, that -2, that's what we start off with at the beginning with the gradient of my parallel line. So that's how I get this value over here. And b is equal to 11 just comes from me solving it in the second part there. Okay, that's the first example here. Second one, last example to go. Find the equation of a line that is perpendicular to y is equal to 1/4 x minus 1 and passes through 3, -2. Okay, with these questions, same first step. Y is equal to mx plus b. First step, I just write down my equation of my line. Okay, from there, we want to find the gradient. Now for this one, we want to find the line that is perpendicular to y is equal to a quarter x minus 1. Now if it's perpendicular, when the two gradients multiply, they will need to give me negative 1. So here, this line has a gradient of 1 over 4. So what I want to do is my gradient over here, m, when I multiply it with 1 over 4, it needs to give me negative 1. So here, if I want to get rid of that 1 over 4, I need to divide by 1 over 4. So this just becomes m is equal to negative 1 divided by 1 over 4. Or the other way, actually, let me just do this first. So negative 1 divided by 1 over 4. So that gives me negative 4. So that tells me that my gradient here is just going to be negative 4. Now that's one way that you can solve it. You can also, to get rid of this fraction, you can just multiply both sides by 4 as well to get rid of that denominator. That's another way that you can do this. Okay, so because I have this negative 4, I'm just going to replace it in my equation up here. So what I'm going to write is y is equal to negative 4x plus b. So I've just replaced m with negative 4 that we found from this condition, because we know that this line is perpendicular to y is equal to 1 quarter x minus 1. Okay, that's the first part. The second part that we need to do is then we need to substitute this into that point. We need to substitute that point 3, negative 2. So I'm going to write down my point here, 3, negative 2. And so my x value is 3, my y value is negative 2. I'm just going to substitute these values in. So wherever I see x, I'm going to replace it with 3. Wherever I see y, I'm going to replace it with negative 2. So here in my equation, that just becomes negative 2 on my left-hand side here for y is equal to negative 4 times 3 plus b. Okay, let's just fix this up a bit. So on my left-hand side, I have negative 2. That doesn't change. Negative 4 times negative 3 will give... negative 4 times 3 will give me negative 12 plus b. And then when I start solving for this, what I want to do is just move everything to... make b be alone by itself. So I want to move that negative 12 to the other side. So when I move it to the other side, it becomes a plus 12. So here, this becomes negative 2 plus 12 is equal to b. So therefore, b is equal to negative 2 plus 12 will give me 10. And so once I've got this final answer, all I need to do is just put it back into my equation of my line. So here I had, therefore, y is equal to negative 4, which is what I found at the beginning about my gradient, x plus 10. And so that's my final answer. So here, my negative 4 comes from my gradient at the beginning, and the 10 comes from that y-intercept that I solved for there. So that's how we find the equation of a parallel or perpendicular line given these conditions. So let's just sum up what we looked at in this lesson. In this lesson, we talked about what parallel and perpendicular lines are. Parallel lines are lines that never intersect, and for them to be two lines to be parallel, we need to have their gradients being equal. Perpendicular lines are lines that intersect at 90 degrees. And so in order for us to actually have this, we need to have the two gradients multiplying together to give me negative 1. From here, we were able to actually identify whether or not two lines were parallel or perpendicular by identifying their gradients and then just seeing which of those rules it matched up with. If the two gradients were equal, that meant that they were parallel. If they multiplied together and gave me -1, it meant that they were perpendicular. Then from there, we were able to actually find the equation of a parallel or perpendicular line. And so the 3 steps that we followed were, we wrote down the equation of a line, we figured out what the gradient was based on the condition, so we checked if it's parallel or perpendicular to another line or another gradient, and then we substituted our point in. So that's how we answer these questions. If there's any questions or if I didn't explain something, you can have a look back in the video earlier and maybe watch it again, or as always, you can email me or send a comment in the Google Classroom. But that's it for this lesson, Year 10s, and until next time, I'll see you in the next lesson. Bye!